Good morning, students. Now we will see the revision aspects on the topic, namely redox reactions. Redox reactions, the respective their equations, redox equations. Before that, let us revise what is meant by a redox process. So redox process is one which involves both oxidation and reduction. Once again, oxidation can be defined in three different ways. The converse definitions give rise to the definitions of reduction. So both are defined in terms of oxygen, in terms of hydrogen, in terms of electron. So addition of oxygen to a species is called oxidation. Addition of hydrogen to a species is called reduction. Addition of oxygen is called oxidation. Addition of hydrogen is called reduction. Similarly, a system is said to be oxidized if hydrogen is removed from the system. Removal of hydrogen. Whereas removal of oxygen refers to reduction. So, removal of oxygen. Then lastly, in terms of electron, it is called electronic theory of oxidation. So, addition of electron to a system, the system is said to be reduced. Removal of electrons from the system, it is said to be oxidized. Whenever we remove an electron from a system, it acquires positively charged in nature. So, it acquires positive charge or positive charge character increases. So, there is increase in positive charge. The increase in positive charge or the change in charge is called oxidation number. So, they are collectively called redox process, but in due course only the oxidation number is used. So, oxidation number we will see. These are to be points to be noted for the definitions of redox processes. Oxidation is either addition of oxygen or removal of hydrogen or removal of electron. Reduction is the process of addition of hydrogen or removal of oxygen or addition of electron. So, the substances are broadly divided into oxidant and reductant. Materials are divided into two types, oxidant and reductant. Oxidant is a substance which can add oxygen to other species, which can enable oxidation process. Similarly, reductant is the substance which can add hydrogen or electron or remove oxygen from the adjacent system, so that it is called reductant. So, oxidant and reductant. Generally, because why they are interconnected, any oxidant automatically undergoes reduction. So, oxidizing agent undergoes reduction, reducing agent undergoes oxidation. We will see all of them in detail. First, let us list the types of oxidants, which are the materials used as oxidants. So, directly oxygen or ozone or halogens, they are used as oxidants, because oxygen, whenever a system is there, on addition of oxygen, some compound is formed, metallic compound or whatever be the case, metal oxide, addition of oxygen. Addition of ozone can also form metallic compound. Here metal is there, metallic compound. If you compare metal and metallic compound has additional oxygen. Metal has no oxygen. So, this is oxidation. So, oxidation can be affected either directly by oxygen or even ozone, because ozone undergoes decomposition to give rise to oxygen. So, two molecules of ozone undergo reversible decomposition to form three molecules of oxygen. That is another source. Now, the role of halogens for oxidation. Halogens drain electron from adjacent system, forming halides. So, it is a halogens undergo reduction. Addition of electron is reduction. Halogens are reduced means that additional species, the other species is oxidized. For example, even the reaction between hydrogen and chlorine to form hydrogen chloride is a redox process. Here hydrogen state, it has two, we will see about the oxidation state bit later. So the oxidation state of hydrogen in the reactant side is 0, whereas the oxidation state of hydrogen in product side is, it is H plus Cl minus. So oxidation state is plus 1. So increase of positive charge or increased oxidation state refers to its oxidation. So hydrogen is said to be oxidized by halogen. So halogens can be used as oxidizing agents. Second, sources for oxidation or which are materials serving as oxidants are oxides. Oxides of both metals and non-metals. Metals as well as non-metals, their oxides are also used. For example, magnesium oxide, magnesia, chromic oxide, chromium oxide. These are metal oxides. Carbon dioxide, water. So water is a significant one. Water H2O2, because we define oxidation and reduction both in terms of hydrogen and oxygen. But these compounds are compounds of hydrogen and oxygen only. So they will play dual role in all the media. Third one, which materials can be used as oxidants or oxidizing agents? Those with higher oxidation state. We will see what is meant by higher oxidation state. So we have seen about chromium. So chromium, all the chromium salts or all the chromium compounds cannot be used as oxidizing agents effectively. Potassium dichromate. Potassium chromate is a compound. Potassium chromate is K2CrO4. Potassium dichromate is K2Cr2O7. This one is more powerful oxidizing agent than potassium chromate. This is more powerful oxidizing agent than this chromic oxide. All are chromium compounds. That is, so systems with higher oxidation state can serve better as oxidants. Similarly, permanganate, potassium permanganate can be used. So these are some of the oxidizing agents or oxidants. Similarly, what are meant by reductants? So reductants are the materials used for reduction purpose. As the phenomenon involves, they undergo auto-oxidation. So that is to be noted. Any material which serves as oxidizing agent is getting reduced, which serves as reducing agent getting oxidized. So reductants can be elements with metallic or non-metallic states. For example, zinc, tin, these are used as, tin HCl is used as the reducing agent. Non-metallic elements, carbon. So carbon is used in metallurgy. So metal oxides, metal oxide can be generally represented as M2ON. So metal oxides, when react with carbon, carbon is nothing but one of the forms of carbon is charcoal. So metal oxides, when heated in Bessemer converter or any other furnace with charcoal, which is a form of carbon, it is converted to metal and carbon monoxide. If we balance two parts of metal are the 2M. So if NCO, so n number of carbon atoms combined with the n number of oxygen of metallic oxide to form. So here this process in general, M2ON plus NC giving 2M. 2M is metal is solid and NCO carbon monoxide is gas. Metal oxide may be a solid, this one is solid, this is gas. Here this carbon is used as the reducing agent. Reducing agent means metal oxides are reduced to metals. Reduction means removal of oxygen, also reduction, removal of oxygen. Even the same carbon can be reduced to methane. Carbon to methane conversion is called reduction because carbon is added with hydrogen to form carbon. If it is added with oxygen, carbon dioxide, it is oxidation. In certain cases carbon is oxidized, in certain cases carbon is reduced. So it depends on the environment. Another example of reductant. In the case of oxidant, we have seen that metal oxides can be used. Here hydrogen is the source for reduction. Second type of compounds used as reduction are what are called metal hydrides. Metal hydrides. Metal hydrides have the general formula MHN, where N is the valency of the metal. For example, if we write NaH, sodium hydride, sodium has a valency of 1. CaH2, calcium hydride, calcium has the valency of 2. And ammonia, nitrogen has the valency of 3. Methane, carbon has the valency of 4. These are hydrates, but they can be metal hydrates and non-metal hydrates. Metal hydrates are more effective. Non-metal hydrates are also used in certain cases as reducing agent. So, preferentially used ones are metal hydrates. Third choice, those with lower oxidation state. Similar one. There we have seen that those with higher oxidation state, they are used as oxidants. Species with lower oxidation state are used as oxidizing agent. Example is oxalic acid. Oxalic acid can be. So, let us compare these two acids or three acids, H2SO4. H2SO4, nitric acid can be used for oxidation purpose. Sulfuric acid are also sometimes used as oxidizing purpose, but oxalic acid is used for reduction purpose. So, we cannot generalize that acids are used for only for oxidation or for reduction, depending upon the oxidation state of the particular element or presence of oxygen content. Here oxalic acid has enormous amount of oxygen. Sulfuric acid has enormous amount of oxygen. But that is also it contains replaceable hydrogen atom. It is a supplier of hydrogen atom. So supplying hydrogen or supplying oxygen, which is predominant, accordingly that decides the nature of material as the reductants. So far we have seen about what is meant by oxidation, reduction, what are the collective process is called a redox process, what are meant by oxidants and reductants with examples, which type of materials can serve as oxidant and reduction. A reductant, here we have seen that metals with or elements with higher oxidation state or lower oxidation state can be used as oxidant or reductant. There is one definition goes. Here we have to have recall the knowledge of what is meant by oxidation number, how is it to be calculated. So now we will have a brief definition or outlook of oxidation number, then we will see the in-depth aspects of oxidation number, its calculation in different compounds. So oxidation number, it is also called oxidation state. Oxidation state or oxidation number is one which prescribes the material selectively for oxidation or reduction. Oxidation or reduction. This oxidation number can be positive or negative or even 0. Oxidation number is positive means it is in the higher oxidation state. Oxidation number is negative means it is in the lower oxidation state. Even if you compare two or more positive numbers, less positive is lower oxidation state, more positive is higher oxidation state. Similarly, negative numbers indicate reduction status. The systems with negative oxidation states used for reduction. Once again, in the comparison of negative numbers, more negative means it is a better reducing agent. More negative means it is a better reducing agent. More positive means it is a better oxidizing agent. But 0 means it is neither an oxidizing agent nor a reducing agent. In some case, for example, CH4 we tell. CH4 oxidation state, it is a covalent compound. So we have defined oxidation or reduction in terms of only charge, loss of electron or gain of electron. Whenever a system loses electron, it becomes more positively charged. Gains electron, negatively charged. But covalent compounds are formed by sharing of electrons. They are not transfer of electrons. In that cases, only oxidation state as a whole is viewed. Oxidation state is 0 or whatever be the case, but for the individual systems, we have to note down starting from the element hydrogen, we will see. Now, we will revise the concepts on the oxidation number. Let us say oxidation number is generally the number of positive charges associated with the system. More positive means higher oxidation state, less positive means lower oxidation state, but in the case of negative, more negative means lower oxidation state. In that way, we got 0 means neither oxidation, redox status is 0. That is neither oxidation nor reduction. Let us see but this oxidation number can be positive, negative, 0 and also fraction. So, it is also defined as real or imaginary charges. So, a question may arise, what is meant by imaginary charges? For example, let us see the case of KMnO4. So, for the calculation of oxidation state, hydrogen is always, the state of oxidation state is generally taken as +1 in its compounds. In acids, most of the compounds, in ionic compounds, it is taken as +1. But only in type of compounds called hydrates. Just now we have seen about the type of compounds, hydrates. Only in hydrates, the oxidation state of hydrogen is taken as -1. All other compounds, ionic compounds, hydrates also ionic compounds. All other ionic compounds, hydrogen oxidation state is taken as +1. In the case of covalent compounds, oxidation state of hydrogen is taken as 0. So, hydrogen can take any oxidation state, 0, positive or negative. Means that it has lost an electron, its charge is +1 in some compounds. It has gained one electron, so its state is -1. It is neither losing nor gaining but sharing electrons with adjacent system, its oxidation state is 0. So, oxidation state only for hydrogen, this one, that is to be noted. So, generally for most excepting hydrates, all other ionic compounds, oxidation state is for hydrogen is +1. For metals, the charge, metals generally they lose electron to form metallic cations. General electron redox reaction for metal is, metals have the capacity to lose electrons. For example, Na means loses 1 electron forming Na plus electron. Calcium loses 2 electrons forming calcium 2 plus, and aluminium loses 3 electrons, Al3 plus, etc. So, metals generally lose n number of electrons to form the respective cations, metallic cations. So, how many number of electrons lost or gained or transferred from one system to other system, that defines the oxidation state. So, oxidation state can also be defined as the number of electrons transferred from one system to other system, or number of electrons lost or gained by one or other systems but not shared. So, now sharing is not coming here, only complete losing of electrons, because only after complete losing one becomes positively charged, another becomes negatively charged. But whenever there is a sharing, none of them is ionic. It is methane is a covalent compound only. Methane, but sodium hydride. So, sodium hydride, calcium hydride. Let us compare these two compounds. Calcium hydride and water. So, calcium hydride, hydrogen oxidation state is -1 because calcium is a metal, its oxidation state is +2. That is why it oxidation. Here, the oxidation state of hydrogen we cannot tell. So, it is a covalent compound 0. For oxygen, we have to fix and then write. So, that is to be noted. Number of charges transferred from one system to other system. So, here for potassium is a metal, its oxidation state is +1. So, we don't know the state of oxidation state of manganese in this case. Why this question arises? What is meant by imaginary charges? There the doubt we are dealing with. That is to be noted. Oxidation state of potassium is +1 plus oxidation state of manganese we don't know. Let it be X plus 4 into, there are 4 oxygen atoms, 4 into oxidation state of oxygen is generally 2 because oxygen will gain 2 electrons to form oxide. Outermost orbital of oxygen, outermost shell of oxygen contains 6 electrons. If it gains 2 electrons, 6 plus 2, 8 electrons, it acquires octet or inert gas configuration. So oxide is more stable. So it gains electrons means the oxidation state for oxygen is 2 because it gains. Number of electrons gained or lost is the oxidation state. Here oxygen gains 2 electrons. So oxidation state of oxygen along with the charge you got to write -2. Since it gains 2 electrons, oxidation state is -2. So overall it is a neutral compound. Oxidation state is 0. So we got to form the equation like this. Potassium oxidation state is +1. Manganese we have to find. There are 4 oxygen. Each oxygen has an oxidation state of -2. So we have to solve this equation. 1 plus X minus 8 plus into minus 4 2s are 8 equal to 0 or X minus 7 equal to 0 or X equal to 7 or X equal to +7, which means that oxidation state of manganese is +7. Oxidation state of manganese in this compound is +7. +7 means what does it mean? It has lost 7 electrons to form Mn7+. +7, what is oxidation state we have defined as charges. The number of charges or number of electrons lost. Manganese has to lose 7 electrons to acquire this charge, or it is not possible practically. Whenever we lose one thing or 2 things, we will be extremely careful. We may not be losing up to the loss of 7 things. So oxygen cannot be, even if it loses 1 electron, manganese, if it loses 1 electron, it becomes manganese plus. Manganese plus is positively charged. Electron is negatively charged. Opposite charges attract each other. So it may not allow the second electron to lose. Second electron, at least for the second thing you will be careful. Third thing you will be extremely, you will not be careless means we will be losing any number of electrons. That is different. So here the imaginary, but charge is there for manganese. Manganese +7 is the oxidation state. That is why it is called imaginary charges. Oxidation state means by the solution of this equation, some number will be assigned to the species. Similarly, you can calculate for the oxidation state of chromium. Now let us revise this concept. General question, calculate the oxidation state of chromium in these compounds. They will ask K2CrO4 and K2Cr2O7. Calculate the oxidation state of chromium in these compounds means in a similar manner. First let us say K2CrO4 example. Potassium +1. There are 2 potassium ions. So 2 into +1 plus chromium oxidation state we don't know plus 4 oxygens are there, each having an oxidation number of -2. So 2 plus X minus 8 equal to 0. X minus 6 equal to 0. X equal to +6. So oxidation state of chromium in this compound is 6. Here also it may come to 6. We will see. K2Cr2O7. So 2 into 1 plus, here there are 2 chromium atoms. Each has oxidation state of X. We have to find 2X plus 7 into -2 equal to 0. So 2 plus 2X minus 14 equal to 0. 2X minus 12 equal to 0. 2X equal to 12 or X equal to 6. In both the compounds, oxidation state of chromium is 6. But here there is more oxygen availability. Potassium dichromate contains 7 oxygen atoms. Here only 4 oxygen atoms. Enormous oxygen atoms are available for oxidation. That is why potassium dichromate is more powerful. Both are oxidizing agents, no question. Both are oxidizing agents. But potassium dichromate is more powerful. Both are compounds of potassium, chromium and oxygen. But potassium dichromate is more powerful because of the excessive oxygen content, and also in any case the oxidation state is more than 5. For manganese we have found it is 7, here it is 6. So oxidation state more than 4 to 5 means it is a very good oxidation agent. Even the simpler compound, very first we have seen Cr2O3. So 2x plus 3 into minus 2 equal to overall is 0. So neutral compound 2x minus 6 equal to 0, x equal to 3, x equal to plus 3. It is, even it has a positive oxidation state. So it has a capacity to be oxidized. But oxidizing power is low, that's all. But it is a very good oxidizing agent. So in this way we have to find. So in all these cases we have seen that oxidation number is only charge, positive charge, higher charge. It can be 6 plus or 7 plus or 5 plus. But the atom cannot lose 5 or 6 or 7 electrons to form the respective positive charge. That is why it is called imaginary charges. It has nothing to do with, there is no, should not misconcept that it is an imaginary process. Not the process is imaginary. Process is always real. The calculations account to be right. That is to be noted. This is made by oxidation number. Now we will see some example with oxidation number negative. Oxidation number negative. So far we have seen oxidation number of chromium is positive. Manganese is positive. In that case, what is the oxidation state number for certain systems to be negative? We will see such examples in due course.